This lesson is going to focus on the confirmation of our geometry initially after building a project. The windows I'm going to show you today on this lesson will be useful to you at all points in the program, because what happens is when the program builds a project, it's actually building shot and receiver tables and trace tables, and these are actual spreadsheet type tables that we have total access to, where we can modify a plot, add columns, and in fact the program itself is going to be adding columns as we compute statics, delay times, models, and things like that. At the end of the last lesson, I left you in this dialogue here where we were coming around and confirming our relational information. So I'm going to add a few more comments about this window. So what I showed you was the relational information here, and I showed you how you can actually plot other things in this window, like elevations, for example. But we can also bring up a shot table. So here's our first look at the shot table that the program has built in the data, a shot as part of our database. So if you move around here, for example, you can see the differences in coordinates. You can see we have initial easting and northing. We have easting and northing here. These are, the reason we have two sets of easting and northing is when we, later in the program, we have the ability to move shots and or receivers based on the trace information. We have a geometry analysis. So the initial easting and northing tell us where we came from. So if we move a shot, the easting and northing will reflect the new position of that shot. So we can actually compute the distance moved, and the easting and northing represent the current location. So when you export, if you want to export the new geometry to your Omega or Promax databases, for example, it'll be the easting and northing, these values here, that you'll be exporting. But this is where they came from. Or if you find that you move a shot and the original location was correct and you moved it for bad reasons, like for example mispicking or whatever, you can restore it back to the initial easting and northing quite easily. But anyway, as you can see, this is quite useful just as an initial look at the data. And we have the same thing for receivers. So when we move around this map here on receivers, we can see what's going on there. And we also have a thing for imported data. Now we don't have imported data in here, but sometimes in large surveys they may have an independent uphole survey, for example. That information can be brought in. Perhaps it's on XY locations that have nothing to do with our shot receivers. They may be, some of the shots, some of the upholes may be within the survey. Others could be external to the survey that are going to get interpolated into the survey. So that information would be shown here, and you could actually look at it directly in this window. But you see we have other tabs up here. The next tab is the receiver tab. This receiver tab allows us to look at the receiver part of the database in a spreadsheet. So you can see here I have several, all the data, all the columns that are in my database that currently exist. This table will flesh out later when we're computing delay times. Delay time will show up here when we compute statics, when we have elevations for models, velocities. Those will all start to show up as options here. So we can either select these, or we can actually run a query. And when we run the query with nothing in there, it just says show me everything. And as you can see, we also have all kinds of options here. I'm not going to go into those right now. You can play around with these. But these columns here are, if you click on the top of the header on each one of these columns, it sorts up and down, up descending. And so if we wanted to look at the low fold or the high fold receivers, in this case, we could do that. Or if we wanted to look at, as you can see here, we have an awful lot of information. And if I wanted to look at, let's say I really don't care about the polarity at this point, my initial X's and Y's. They're just really cluttering up my view here. So let's look at a much more limited view. So let's say I want to look at easting and northing, elevations, and fold at this, and line number and and point number. So this is a much more limited view. The extraneous, what I consider extraneous at this point, is no longer cluttering my view. We can save this current query, and then later we can look at open prior queries dialog and actually go back and retrieve that. I'm not going to show you that. You can play around with that again. Now, we can also cross-plot values. So here I'm going to plot easting versus northing. So I'm going to have a map view, and I'm going to plot elevations, since I really don't have many other things that are of any interest. So I reload the plot, and so from my receivers you can see my elevations. Import conflicts, this is not an option to import conflicts. This actually means that there were some conflicts when we were importing our geometry. If you recall from the first lesson, the program reported no conflicts for my shots and receivers when it was building the project. If we did have them, they would show up here. But since we don't have any. So here we have, here's our elevations. So now let's go back to the table here. And when I first built the project in the first lesson, you recall that I had line numbers. You may recall that I had line numbers that were I divided by 1,000, and because I wanted the first 3 digits of a 6-digit number. Well, I didn't do that when I built this project, because what I'm going to do is show you how to do this interactively. So what I'm going to do is I'm going to do a column modification, and I'm going to do column math. And I'm going to create something. I'm going to take the line number. Let's pull this off to the side here so we can see the names of these columns here, because you want to get these exactly right. But I'm going to say line number equals point number divided by 1,000. Okay, so I want the first 3 digits of this number 109, in this case 109, 101. I want 109 to be the line number. And if I go on ahead to the shot table, you'll see that I had the same issue there, that my line numbers are all 0 and my point numbers are these 6-digit numbers. So I'm going to take this point number divided by 1,000 and put it in the line number, and this will truncate, since this is integer math, it'll truncate the last 3 digits. So I'm going to update the shot, yes. Update receiver, yes. And I've already done this before, and I saved the current statement. Okay, so I could have just clicked on this. So if I erase this and then clicked up here, I could have done it that way. Okay, but in this case, I was pretending I didn't create this. But later, you may want to do this. So if you have some complicated math statements, you can easily save these and retrieve them later. And these are just example ones here, and you can actually bring these up too if you want. You can actually you can click on these, our example ones. Okay, so anyway, I'm not going to do this math. Obviously, I don't want to do this at this point. So I'm going to exit this. And now you can see that my line number for my receiver is indeed the first 3 digits of this 6-digit number. So, and in fact, let's plot those. So let's go to the cross plot here, and let's look at the line number. And reload the plot, and as you can see, there's a systematic change in the line number. And at this point, let me just do a little side here and show you how you can interact with this database here. First of all, if you want to change a particular color, you can actually just click here and change a color. Let's say you had a very specific thing like 0 happened to be on elevations. You wanted to see where sea level was on your map. 0 would do that for you. I mean, you would click on there and change that color to black or whatever, and you could see that wherever you saw black, that would be 0. You could also turn off colors, and some of our previous programs, like Stratus and Seismic Studio, you would actually drag on the color bar, and here you drag on the number bar. And what's nice about it, yeah, it's nice and graphical. And if you want to restore the colors, you say clear dead. Okay, so you can see how I'm turning off certain colors. In this case, I'm turning off line numbers because the line numbers happen to be my axis. And then I'm going to clear dead again. I can also change the scale quite easily. So here, if I wanted to change it to 110, I just wanted to look at the ones from 0 to 110, 101 to 110. You can see I've eliminated the ones that are greater than that. I click this and I get them all back. I can right click on the scale itself and I can look at different options, different color options here. Very easy. Let's go back to our default. Okay, so that's the color bar, little side there. Now I'm going to, okay, so that's, now the other thing is on my table here, what I want now is I want the point number to be the last 3 digits of this 6-digit number. So I'm going to go back into my column math here, and I'm going to say that the point number, let's pull this off here to the side, the point number, all caps, equals point number minus line number times 1,000. Okay, so what I'm going to do is I'm going to take the line number, divide it, multiply it by 1,000, so it'll be 109,000, subtract it from here, so I'll get that 101 this way. So this is a useful thing, especially in this particular data set, and perhaps I have other seg Ys that I'm going to be building other projects from later, so I'm going to save this one also. So now let's update the shots, say yes. It doesn't update it automatically. You don't see it reflected in the database yet, but you will as soon as I exit this. And let's update the receivers since they both have the same issue. Now when I exit this, you can see my point numbers are indeed changed to be the last 3 digits of those numbers. So again, let's just have a look at it in a cross plot. I will look at the point number here, reload, and you can see again a systematic change from east to west, where the line numbers are changing from north to south. Okay, so and now let's go to the shot table, and I'll just run query, which will show me all the columns, and you can see my point numbers and my line numbers have the same behavior. They have they have a 3-digit number here, a 3-digit number here. Let's look at the cross plots. We'll do easting, northing, and we'll look at the line number. And reload plot. And you can see the line numbers are changing from east to west systematically. If I wanted to turn off, whoops, have it there. I'm going to turn off some of these line numbers here. I can easily do so. Clear dead, and to restore them. And finally, let's look at the trace table very quickly. The trace table is very fast. This is a open SQL database. It's very good at handling things quickly. All the traces are here. We can do column math, set columns. I'll play around with this later, or we can play around with our pick times, for example, whatever. But anyway, all the traces are easily accessible via this. Even if there's 100 million traces, you can this actually works just as quickly. So we're very happy with the behavior of this. And when you create user picks, for example, they're going to show up in the FB pick user, FBP user column. But as you can see, we have several columns available to you for managing different types of pick times, like auto picks will come into here, predicted picks. So they're going to show in here, and they're accessible to you to not just look at, but to also to modify as you will. Okay, so that's the end of this lesson. On the confirmation of geometry, you will want to use these tables a lot. Our expert users, the more the expert the user, the more they use these tables to manipulate their data. You can kill these tables right now, for example, just to clean up your interface, but you can always bring them back here at any time using under database here. So that's the end of that lesson. Thank you very much.